All right, guys, today we're going to work on section 5.2, verifying trigonometric identities. It's really similar to the past section, 5.1. It's going to be a little easier, I think. Actually tell you what it's supposed to equal, so you kind of have a roadmap as to where you're supposed to end up. So I do like that a little bit better. Now, just looking at some of our Pythagorean identities, just some different things to look at. Of course, see these squares, you should be triggered right away. You need to look at the back side of your identity sheet to look at your Pythagoreans. I just wanted to show you quick. It looks like there's a lot of them, but really they all hinge off this main Pythagorean identity. So I can fill in everything on the right-hand side over here just off this one equation. Because I'll be honest, I can't say as I necessarily always have all of them memorized, but I can manipulate this equation I highlighted in red and make it happen. Easy enough to get sine squared alone. You could just ignore the bell. You could subtract cosine squared from each side. So I'm going to fill it in over here. I've got sine squared as 1 minus cosine squared. I could do the same thing and get cosine squared by itself, so I'm going to erase that. Let's erase all this red and get it out of the way. If I want to get cosine squared by itself, I subtract sine squared. So that's easy enough. I can do that in my head almost. Cosine squared is 1 minus sine squared. So those, of course, are the obvious easy ones. Now, to get the remaining 4, here's where we got to get a little creative. It's just about manipulating this equation. I'm going to go through and divide everything by sine squared. And again, as long as you do the same operation every term on the equation, equivalent. Sine squared over sine squared, 1. Cosine is cotan, but of course squared. The darn bell. Okay, 1 over sine cosecant, and of course squared. So now I can look over here and I know cosecant squared, 1 plus cotan squared. And you could have that reverse, cotan squared plus 1. Now I could also fill in cotan squared, because if I want to solve for that, I would just subtract the 1 off. So now I know cotan squared is cosecant squared minus 1. Okay, I'm going to erase what I've written in blue, and I'm going to go through and do a similar process, but instead of dividing everything by sine squared, I'm going to divide everything by cosine squared. And let's see what we get. And again, as long as you do the same operation to every term in the equation, it is equivalent. Sine over cos, tan, but with the square. Cosine squared over cosine squared is 1, and 1 over cosine secant. So now I know that secant squared is tangent squared plus 1. I can fill that in. And I know tangent squared, I can get that by itself. I'm just going to subtract 1 from each side. So secant squared minus 1. So just showing you that all of these Pythagorean identities really hinge off the main sine squared plus cosine squared equals 1. Of course, you get to use your identity sheet, so be looking at that closely. All right, to try to give you some guidelines, some hints as to how to approach these problems, that's what I have next here on your notes for you. First off, key, you are showing me that one side of the equation matches the other. So you only work on one side of the equation at a time. It may seem counterintuitive, but I think it's easier with the more complicated side first. It's easier to try to take something that has a lot of terms in it and try to simplify it down to an easier expression versus doing the other, going opposite. Okay, look for opportunities, of course, to factor. We've seen a lot of factoring. Add fractions. Don't forget adding fractions, your common denominators, squaring binomials, or a monomial denominator. Multiply by the conjugate. You look for opportunities to use your fundamental identities. Look at what functions are in your final expression. Again, sine and cos pairs up well, so does secant and tangent, cosecant and cotan. Number 4, here's the pro tip. I've been mentioning this since day 1. If you're stuck, put everything in terms of sine and cosine. But the key is you can't just sit here and stare at the problem. You have to try something. And you will see, if you look on my answer keys, there are times I tried something and I was like, gosh, I just don't know if this is going to work out, or it seems like I'm taking the long route. So I would erase it and try using a different identity or a different process. But you have to try something. I can't just tell you, hey, follow the rule X, Y, Z, and you'll always get the right answer. Every single problem is a little different. Okay, so here we go. Now, Identity. Here's what I'm talking about. I think these are a little nicer because you know what you're supposed to equal. They're giving you the answer. So first we're going to figure out which side are we going to work on, the left or the right. I can't really say just looking at it, I think one side is easier or less complicated than the other. But if I had to make a call on it, I would say the left side looks more complicated just because one on the right, I mean, one's pretty simple. So I'm going to work on the left side. I think that's the more complicated side. So I see I'm trying to just have something that has tangent squareds in it. So it would be nice if we could get rid of the secant squared and replace that. So I'm going to leave my original front tangent squared. I like that. Secant squared, that is on your identity sheet, on your green Pythagorean identity sheet. Secant squared, tan squared, plus 1. Looking good, because now I'm going to combine those like terms. 1 tangent squared plus another tangent squared, 2 tangent squares. Now, I'm not saying you can't do it if you start on the right side. It's just every process is different. There's more than one right way to do it. It's however you want to start it. I thought the left looked a little more complicated, so that's why I chose that one. All right, clearly I think the left's more complicated here because we have, of course, more functions on it, more terms. Again, I see right away it jumps out to me, identity. Tangent squared plus 1, secant squared. So I'm going to replace that right away. I still have the cosine in the front. Now, we're trying to equal secant. So what I'm going to do is rewrite cosine. We need to eliminate the cosine, so I'm going to use an identity. It's 1 over secant. I can't write and talk here. 1 over secant. Got it. And then, of course, we can reduce the secants down. I'm going to take secant out of here, reduce the secant out of there. We've got it. So the key on we know what the answers are, what they're supposed to equal. It's all about showing me the work. I need all the steps. I need you to show me why it does equal the answer that it does. All right, let's take a look at letter C here. Clearly, I think the left side is more complicated. And right away when I'm looking at these terms, I was like, ooh, we have signs, multiple signs. So I'm going to use one of our favorite F words here. I'm going to factor a greatest common factor sign out. So to get my first term back, I need 2 more signs. Get my last term, cosine squared. All right, look on your Pythagorean identities. Whenever you see squares, of course, Pythagorean identities, sine squared plus cosine squared, 1. So I got that right off the green sheet. I still have the sign in the front. And obviously, sine times 1 equals sine. We made it. So again, not crazy complicated, not a lot of steps, but a little time consuming. All right, let's take a look at this guy. I'm just going to move it down a little bit here so we can reach it. So obviously both sides look pretty complicated to me, but if I had to pick a side I think is a little more involved or more difficult, I would say the left because of the square root. So I'm going to work on that. Now, just so I have some room to write, I'm going to rewrite the square root underneath. I'm just worried of trying to cram anything in there. We won't be able to see what I'm writing. Now, this is, I'm going to go back to kind of some of these hints here that I gave you at the beginning. So when it talks about, of course, squaring binomials, create a denominator, multiply by the conjugate. I'm looking at number 2, multiply by the conjugate. That's the little tip I'm going to use on this guy. Because I'm like, wow, these are pretty easy. They're signs, not squared, so I can't use Pythagorean. So I'm going to multiply by the conjugate and make that monomial, single term, denominator. Okay, so denominator is 1 plus sign. We're going to need a 1 minus sign. So I'm putting this on top and bottom. Our original expression's under a radical, so this would be 2. What I wrote in red is really a form of 1. Same thing over the same thing. So we're multiplying by a form of 1, so it's going to change the look of the fraction, not the value. So let's see what we've got here. So both under radicals, everything's under radicals, so we can multiply them together. So 1 minus sign on the top times 1 minus sign. I'm just going to put it 1 minus sign squared. Think about squaring in a square root right now. Bottoms I'm going to FOIL out, 1 times 1. The middles cancel, sign and negative sign. Okay, I'm going to move up here because I'm running out of room. So the top, of course, nice and easy. We know that's going to simplify. I'm going to handle that in a minute. But what also jumps out to me is this 1 minus sine squared. That's an identity. It's cosine squared. Well, now squaring, square root, of course, cancels. Square and the square root on the top cancels, so I have 1 minus sine. square and the square and cancel on the cosine. And we got it. So to me, I think what I wrote in red is the key step, and that's probably the hardest one, to just pull that out of the air and kind of magically think, oh, I'm going to multiply by the conjugate. What made me think of that, or why I did that, I was like, well, these are already very simple functions, sine and sine, no obvious identities. You do have the two terms in the denominator here, so I thought I'm going to try to use the conjugate. When I saw the 1 plus sine, that's what kind of made me think, all right, what if I use 1 minus sine and see what happens? All right, F's a little bit easier here for you. So again, the left side looks more complicated to me clearly, and it jumps out, identity. That is a co-function identity. If you look on your sheet, the co-function to sine, of course, cosine. So I'm going to replace that. We still have, of course, our original cosecant here in the front. Now, I need this to turn out to be cotan. So again, we're going to use some identities. Cosecant, that's 1 over sine, there's an identity. Then I'm like, oh yeah, cosine over sine, got it, cotan. So in the homework's the same way. The previous problem I think was pretty challenging, and then it goes to what I think is a simple problem. So if you get to a tough one on the homework, don't give up, okay? Because the next one could be super, super easy. It's kind of all sorts of different levels of problems on these. All right, clearly the left side's more complicated. We're going to work on the left. Now, adding fractions together, here we go. We need that common denominator. So I see the right denominator sign, so I'm going to put that on the left. I see the left denominator's 1 plus cos. I'm going to sneak it in here. I'm going to put that on the right fraction, on the top and the bottom. Kind of sneaking it in there. Okay. Kind of messy, but we'll work it. So we're going to multiply before we add, so I'm going to do sine and sine. Up to you if you want to distribute out the denominator. What I care about, of course, right now is that they match. I'm just going to leave it. You're welcome to distribute it. On the top, of course, here we're going to distribute cosine times 1, and then cosine times cosine, cosine squared. Same thing on the bottom. You're welcome to distribute. I just care about the fact that they match, so nothing's going to cancel out or anything, make it any easier on me if I do decide to distribute. So we've got our common denominator, so I'm going to go ahead and fill that in. Now, numerator. I'm looking for like terms to add. Sine squared, cos squared, none of those are like terms. But, ding, 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 we have an identity. Sine squared plus cosine squared is right on the Pythagorean identities. That, my friends, remember, is 1. So sine squared plus cosine squared I'm going to put as 1. We still just have a plain boring cosine up here. And I'm like, oh, look at that. We've got a 1 plus cosine and a 1 plus cosine, top and bottom. So those, of course, eliminate. So I'm down to 1 over sine. Running out of room here. Which, of course, 1 over sine, cosecant. Got it. So, yeah, a little more complicated than the previous problem, but we've added fractions. We've made the common denominators. Not awful, okay? So, like I said, easy, hard, etc. So, here I just wanted to give you a little hint to try to help you out. This is number 72 out of the book, of course. You're doing, if you notice, the odd ones, of course. So, just to kind of help you out with 71, 73. Clearly this time, I think the right side looks more complicated. So I'm going to work on the right. I was like, gosh, we got a lot of things here. I see a lot of tangents. So I'm going to factor out a tangent squared. I'm going to use that GCF. So they each have 2 tans in them. We need 1 to hold the place and another tangent squared. And then we have an identity. Shakaruski, 1 plus tangent squared. It's on your Pythagorean identities. Secant squared. And I'm just going to fill in everything else we have left. We still have this tangent squared, and I still have this secant squared. Okay, and I think we got it. I think we've got our left-hand side. Because secant squared, I'm going to combine that to secant to the 4th, and then we still have the tan squared. And remember, the order you multiply in doesn't matter. That's why it's okay that I reverse secant and tangent, so it matches exactly to my left-hand side. So, a little hint there for you. Be on the lookout for a GCF when you get to 71 and 73. All right, try something. Of course, some of these are more difficult than others. Some of them are super easy. So I'll be posting some hints here and there on Google Classroom in the stream, trying to help you out on some of the problems. I might even put together a little homework help hint video for you if you would like an extra resource. But try something. You have to try something. All right, have a great day.